and the genus that I chose was Chlamydomonas. So the taxonomy for the species is in the Empire Eukaryota, kingdom Plantae, phylum Chlorophyta, order Chlamydomonodales, and genus Chlamydomonas. So this is a pretty simple algae. It's unicellular. It has an eye spot that's used for phototropism, so it's able to orient itself and head towards the light. Since it is algae, it has chloroplast, and it needs to go to light for photosynthesis. It has a pyrenoid, which is used for O2 fixation, which is also needed for photosynthesis. And it has two flagella and is isoconic, which means that the flagella are the same length. And it has a U-shaped chloroplast. And it does have a nucleus and a cell membrane in mitochondria, in mitochondria, like other cells. It's just a very simple cell. So it has zygotic meiosis, and it has flagellated gametes that are isogamous, so the gametes are the same size. So it starts off as a haploid entity, goes through mitosis, the gametes are produced, they combine to get the zygote, and then after the zygote, it goes through meiosis and back through to the haploid entity. So because this is such a simple algae, it's been used to model different things such as photosynthesis and light perception, just because it's very well known, it's simple, so they can take kind of what they learned from this algae and see how it compares to other algae and kind of use it as a model and base other studies off of it. So one study that I found, it's interesting that there's not too many recent studies. Most of the studies done on this algae were done like 1960s, 1970s. But this one was looking at how silver nanoparticles, how they're like affecting the algae and they're toxic to the algae. So silver nanoparticles have become more popular because silver has like an antibacterial property. So they've been used in like laundry, detergents, and cleaning supplies and food storage containers for that bacterial property. But these people wanted to see how if it entered the water, what it was going to do to algae. So they also compared it to silver nitrate, and they found, these are two graphs I took from the study, but they found that the silver is actually inhibiting the algae's ability to photosynthesize. If they can't photosynthesize, they can't get the energy and everything they need, the algae will eventually die. But one interesting thing they found is even if the silver particles were to increase, there's supposed to be more of them, that it wouldn't necessarily have a huge effect on the photosynthesis. It's more there's something else in there that's also affecting the photosynthesis. And they used a freshwater species for this study. And this is my lecture cited. Does anyone have any questions?